In this video, we're going to compose functions and then find their domain. To compose two functions means to put them together in such a way that we create a new function. And then when we create a new function, we do have to kind of describe it by saying what its domain is. So let's first compose f of g of x. So that looks like f of g, almost looks like we're spelling fog, f of g of x. And that means we're doing this. We're taking f of x and we're plugging in g of x. These two things here are equivalent. This is how you'll see it written in ALEKS, and then this is how I prefer to write it out. So what we're going to do is we're going to, instead of plugging in a number, we're plugging in all of g of x. So we're going to take x minus 3 and plug it into the f function here. So we're going to take this function, and instead of writing x here, we're going to plug in what g of x is. It's x minus 3. So that's going to get squared. So this is our g of x. I'll write that in white. And then that gets squared. And then we have a minus 2. So I plugged in g of x, x minus 3, into f of x's function. Then we have to just simplify it. So we need to square x minus 3. That means x minus 3 times x minus 3. When you FOIL that out, you'll get x squared minus 6x plus 9. And then, of course, we still have that minus 2 at the end. I'm just color coding it still so you can see what I'm doing. Then we'll combine like terms, and in this case it is possible to do so. We'll have x squared minus 6x plus 7. So this is our new function. This is f of g of x. We've composed and created a new function. Now it's still just a regular polynomial, meaning that there's no x in the denominator, nor is there an x under a root. So the domain is all real numbers. We can plug in anything we want here, and there's no restrictions. Let's go the other way. Let's do g of f of x, which looks like we're spelling goff. And that really means take g and plug in f of x. So now I'm going to rewrite this, but instead of x, I'm going to plug in f of x, which is x squared minus 2. So it's going to look like this. I'll plug it in white. I'm going to have x squared minus 2, and then I'll have still that minus 3. So I rewrote this function g of x, plugging in f of x. F of x is x squared minus 2. So I plugged in x squared minus 2, and then I still had the minus 3. In this case, we can also simplify by combining like terms. This one was easier because we didn't have to multiply really anything out. And so g of f of x is x squared minus 5. Again, this is just a regular polynomial, no x in a denominator, nor is there an x under a square root. We can plug in anything we want, so our domain is all real numbers. I've now introduced two new functions, h of x and k of x. The next composition that we will take a look at is f of h of x. And of course that means plug in h of x into f of x. So I'm going to write out f of x up here and then plug in h. So I'm going to insert the square root of x plus 6 into here. So we'll have the square root of x plus 6, and that ends up getting squared because it's x squared, and then we have a minus 2. When we're squaring something that's under a square root, we just are left with what's inside, the radicand. So we'll be left with x plus 6 and then a minus 2, which will be left with x plus 4. So our new function that we created, f of h of x, is just x plus 4. Again, no x under a square root or in a denominator. We do not have any restrictions on our domain. Let's do one more example. The last one that we'll take a look at is k of g of x. And that means plug in g of x into k. So I'm going to plug in x minus 3 into k. So I'm going to have 1 over, and instead of writing x, I'm going to write x minus 3 and then minus 1. So we'll have 1 over x minus 4. So our new function is a rational function, meaning there is an x in the denominator. So our domain can't be all real numbers. Let's think, what do we have to exclude from our domain? What would make us divide by 0? That answer is 4. If we plugged in a 4 here for x, we'd have a 0 in the denominator. We'd have 4 minus 4. So we need to include all numbers in the domain except 4. So we're going to exclude 4 from the domain by saying our domain goes all the way from negative infinity to 4, but does not include 4. And then it goes from 4, not including it, all the way up to positive infinity. And that is how we compose two functions and find its domain.